Now let's look at logarithms with other bases. Let b be greater than 0 and b is not equal to 1. Suppose we have y equals log base b of x. Then the derivative is dy over dx equals 1 over x times natural log of b. So the derivative of log base b of x is 1 over x times natural log of b. In general, if we have h of x equals log base b of g of x, then the derivative is g prime of x over g of x times natural log of b. So just like before, we take the derivative of the inside and divide by the original function, and don't forget the natural log of b in the denominator. Let's try an example. Find the slope of the tangent line to the graph of y equals log base 2 of 3x plus 1 at x equals 1. I want to find the slope of the tangent line at x equals 1. That means I want to find y prime and evaluate it at x equals 1. So step 1, I need to differentiate this function. Y equals log base 2 of 3x plus 1. In this case, 2 is b in this formula, and 3x plus 1 is g in this formula. So to differentiate this function, I'll take the derivative of 3x plus 1 over 3x plus 1 times natural log of 2. And the derivative of 3x plus 1 is 3. So I have 3 over 3x plus 1 times natural log of 2. Now, plug in x equals 1. So I have 3 over 3 times 1 plus 1 times natural log of 2. 3 times 1 plus 1 is 4. So I will have 3 over 4 times natural log of 2. So this is the slope of the tangent line at x equals 1. If the question does not ask for an approximation, that means it wants the exact answer. So we leave it like this. If it does ask for an approximation, then we convert it to a decimal and follow the rounding instructions. For example, this is approximately 1.08. Now, let's look at derivatives of general exponential functions. Let b be greater than 0 and not equal to 1. Suppose we have y equals b to the x. How do we find the derivative of y, or dy over dx? To do that, we take natural log of both sides. So we'll have natural log of y equals natural log of b to the x. Using the power property of logarithms, we can move the exponent in front. So now I have natural log of y equals x times natural log of b. Now differentiate both sides of the equation with respect to x. The derivative of natural log of y is y prime over y. And the derivative of x times natural log of b is just natural log of b. To solve for y prime, I'm multiplying both sides by y. So I have y prime equals y times natural log of b. And y equals b to the x. So I replace this y with b to the x. So y prime equals b to the x times natural log of b. Therefore, the derivative of b to the x is b to the x times natural log of b. In general, if we have h of x equals b to the g of x, then the derivative is b to the g of x times g prime of x times natural log of b. So the idea is keep the original function, multiplying by the derivative of the inside, and multiplying by natural log of b. Let's try example 6. Find the slope of the tangent line to y equals 3 to the x at x equals 2. So I want to find the slope of the tangent line at x equals 2. That means I want to evaluate y prime at x equals 2. So first, I need to find y prime. I have y equals 3 to the x. Remember this rule? The derivative of b to the x is b to the x times natural log of b. In this case, b is 3. So the derivative of 3 to the x is 3 to the x times natural log of 3. Now plug in x equals 2. Y prime at x equals 2 is 3 squared times natural log of 3, which is 9 times natural log of 3. This is the slope of the tangent line at x equals 2. If the question does not ask for an approximation, that means it wants the exact answer. So we leave it like this. If it does ask for an approximation, then we convert it to a decimal and follow the routing instructions. For example, this is approximately 9.89.